Hello. Now we are going to talk about the set operations, right? So first, we'll talk about the intersections. So there are two ways to calculate the intersection of the set. Let's see that. So here we are getting the two set example S1 and S2. Now, one way is to use the method. We are using S1 dot intersection S2. This will give you the intersection output, right? And the second method is we can use this operator, or we can use this notation. So here we are using this AND notation to denote the intersection thing, right? We can also compute the intersection of more than just two set. So here we have this three set S1, S2, and S3. We can simply say S1 dot intersection S2 comma S3. That will work. And we can also do this. Now let's talk about the union. Again, there are also two ways to calculate the union. Again, for that, let's create a two different set. One way is to use the union method, and the second one is to use the pipe character. We are using this pipe notations, right? We can compute the union of more than two set as well. Let's say that we have this S3 set 3. We can do S1 dot union S2 comma S3. We can do that, and we can also use this pipe character two times. Right? Now let's talk about the disjoint. The two sets are disjoint if their intersection is empty. That means two sets do not have the common value. Then those are called disjoint. Again, for that example, consider that we have the three set. S1 and S2 have some common value and S3 does not have the common value. Let's run this. Now when we try to check whether this S1 is a disjoint of S2, and here we're trying to check S2 is the disjoint of S3. Now S2 and S3 does not have the common element. So it is disjoint, but this first one is not disjoint. So for first one we are getting false, and for the second one we are getting true. Of course, we can also use this cardinality. That means we can check the number of length. Like over here, first we try to check the intersection, and then we check the length. Length is 2, that means this is not disjoint. Here length is 0, this means that these are the disjoint. Now since empty set are falsy, we can also check the boolean of empty set, which will be false. The boolean of set with the one element will be true. Now we can also use this associated true value. Like here we can check that if the intersection between two set, if this is true, right? If there is, like, if this will be a disjoint set, right? So it will print this, or it can be disjoint set or it cannot be disjoint set, right? Disjoint set boolean will be false, and non-disjoint set boolean will be true. Here this is not disjoint, but here this is disjoint, right? Now let's talk about the difference. The difference of the two set can also be computed in a two different way. For that, let's talk about this. Let's create two sets. Now here first we can use this minus sign or dash sign, right, to take the difference. Here we are saying that S1 minus S2, we are trying to take the difference between set 1 and set 2, right? So here again, when we do this, here we'll get the one value 1, 2, 3. So basically we are just subtracting 4, 5 element from this set, and the result is 1, 2, 3. We can also do dot difference functions. This will also work. Of course, with the method, we can use the iterable. Like here, we are saying that S1 dot difference, and then we are passing the iterable value, which is not set. It will work. Internally, what this do is basically it convert this sequence data to a set and then try to take the difference. This is what happening, right? Again, S1 minus S2 is not equal to S2 minus S1, right? These two are totally different, because we are trying to take the difference of S1 from the S2, right? But again, here we have this 4, 5, right? If we'll remove the 4, 5, we'll get the empty set, right? Now, the symmetric difference. Now we can calculate the symmetric difference of two set in two way as well. Like here we have this S1 and S2 two set over here. One way is we can use this method symmetric difference to take the symmetric difference, and other one is we can use this hat operator to take the symmetric difference. What this is symmetric difference. So symmetric difference is, so it's like the uncommon from this set and uncommon from this set. So we'll remove the common word, which is 4, 5. We'll also remove 4, 5 from here, and the value will be 1, 2, 3, 6, 7, 8. Right? You can also take the symmetric difference using this notation. First, we are taking the union, and then we are taking the subtraction, and then we are doing union minus subtraction. That will give you the symmetric difference. Now let's talk about the superset and subset. Now, with the containment, we have the notion of proper containment. That means proper containment means the strict contained that is not equal, and just contained means contained and possibly equal. So it is similar to I minus I less than j. This is a symbol for proper containment, and I less than equal to j is the just containment symbol. Right? So here let's say that here we have this 4 set. Right? Now when we do S1 dot its subset S2, this will give you true because S1 is a subset of S2. But when we do S1 less than equal to S2, we'll get true. Right? But for the strict containment, there is no method, so we can use operator. Here we are saying that S1 less than S2. What this will do? This will give you false. Right? This is what happens. But when you check the equality, this will give you true. But for less than operator, this is giving you false. Right? You can achieve the same thing with this combination of method. Right? Now here we are trying to check whether this S1 is less than S3. S3 is this 1, 2, 3, 4. S1 is 1, 2, 3. What will happen? S1 is lower, S3 is higher. Will get true. Right? Now when we check S1 less than equal to S4, where is S4? S4 is this 10, 20, 30, and S1 is 1, 2, 3. It will not check the element. This will give you false. It is not even an equal value. Not any values are equal. Right? What happens with the superset? Again, here we are saying that S2 dot superset S1. This will give you that yes, it is. But when we do S2 less than equal to S1, we're getting true. When we say S2 less than S1, we're getting false. Right? Again, this is not just the case with the set containment. Let's say that we have these two set S1 and S2, and now as we can see that these two sets are non-empty and disjoint. So containment works as follow. Like here, when we do S1 less than equal to S2, we'll get false. For S1 less than S2, we'll get false. Here also will get false. Here also and here also will get false. Right? Because both are the disjoint set. Now let's talk about the enhanced set method. Now there is a slight wrinkle to some of these operations we just saw. Right? So when we use this operator, right, and 5 character and minus, the way to deal with this set on the both side of the operator. That means here when we use this AND operator, so both side of the value should be set. Right? You cannot pass the list value over here. When you do this, this will not work. But this will work with the intersection method. Right? Again, I have already explained how this intersection method works. Just take this sequence data, convert it into a set, and try to get the intersection. Right? But again, if you have this unhashable object, then that will not work as well. Right? Now this means that when we want to find the intersection of two lists, we can do this. We have this two list. First we convert the list 1 to a set, and then we take the intersection, and then we directly pass the list 2. We can do that. And yeah, this is all about the set operation. Thank you very much.